Hey, what's up guys? This is Geitska from Harmony Science Academy, aka The Twig, back with a new sneak peek of the website me and my partner Simon made on our Dry Ice Bubbles project. Today, we're just going to show the scientific principle ELA component and the social studies component of our project. So our understanding. In the range of pressures that we live in, all close to 1 atmosphere. When solid carbon dioxide is heated, it does not melt to form a liquid and then vaporize to form a gas. It sublimates from solid directly to a gas. We never have a chance to observe liquid carbon dioxide, and so the ice is never wet. It is always dry ice. In our observations, water appears as solid in the wet ice forming on the outside of the solid dry ice. It appears as a liquid in the beaker, and the gas phase of water is also indirectly visible in the cloud that forms above the hot water of the beaker. And in our analysis, all of the energy transferred as heat from the hot water to the cold dry ice will be used to change the phase of the dry ice from solid to gas at the constant temperature of sublimation. And in our chart, we have our beaker number, our indicator, and our color of result. In beaker number 1, we have Bromcrestle green, which gave us blue. In beaker number 2, we have universal indicator, which gave us purple. In beaker number 3, we have phenol red, which gave us red. In beaker number 4, we have methyl red, which gave us yellow. In beaker number 5, we had bromthiamyl blue, which gave us blue. In our scientific principle, we have initially the dry ice contacts the hot water and sublimates rapidly. In short, a thick white smoke pours out of the beaker in a color altered by the indicator. As time passes, the water continues to transfer heat to the dry ice, and the water cools. For our ELA component, we chose the interview. I have chosen Simon because of his knowledge and his insight in our project. For question number 1, why is it that dry ice reacted the way it did with the chemicals? Ammonia is a weak alkali that reacts reversibly with water and alters the pH of the solution into a base condition. When dry ice is added to water, it sublimes to a carbon dioxide gas rapidly because of the solution's temperature is warmer than dry ice. Question 2. What does it take to make dry ice? The carbon dioxide gas is pressurized and cooled to form liquid CO2. The liquid carbon dioxide is injected into either a block press or pelletser. These dry ice production machines have chambers in which, once released to atmospheric pressure, the liquid carbon dioxide converts to dry ice, snow, and carbon dioxide gas. Question 3. Why is dry ice dangerous? Dry ice forms carbon dioxide gas. Although carbon dioxide isn't toxic, it changes the chemistry of the air so that there is a lower percentage of oxygen. There is not an issue in a well-ventilated area, but it can cause problems in enclosed spaces. Also, the surface of the dry ice is negative 109.3 degrees below Fahrenheit, which can easily cause frostbite. Question 4. Who discovered dry ice? Adrien Jean-Pierre Thilaurier. Question 5. What is dry ice used for? Dry ice is simply used for keeping things frozen because of its very cold temperature. Question 6. Why is dry ice called dry ice? Solid carbon dioxide is known as dry ice because it looks like ice and because when it melts, or sublimes, it actually goes from solid straight to gas, no liquid, hence dry ice. Where is dry ice naturally found? Dry ice does not exist naturally on Earth, but it is plentiful on Mars. It has been linked to active processes on Mars such as carbon dioxide, gas geysers, and lines on sand dunes plowed by blocks of dry ice. Question 8. When was dry ice discovered? Dry ice was discovered in 1925. Question 9. What is dry ice made of? Dry ice is made of carbon dioxide gas. Question 10. Is sublimation of dry ice a chemical change? Sublimation is a physical change. When a substance sublimes, it changes from a solid to a gas without going through the liquid phase. This does not result in a chemical change, though. Dry ice is carbon dioxide in the solid phase. And for the social studies connection, we have a brief history of dry ice. Historians agree that dry ice was first observed by a French chemist named Charles Thilaurier in 1835. Legend has it that he was simply observing liquid carbon dioxide in a metal canister, watching it evaporate. After evaporation, he noticed a solid block of dry ice at the bottom of the container. From then, for the remainder of the 19th century, it was observed in labs, but went without practical application until 1897. In 1897, an Englishman named Herbert Samuel Elworthy received a patent for solid carbon dioxide that he used to create soda water for his whiskey. The equipment he had available at the time was fairly cumbersome in this process, and few people used this technique. The first commercial use of dry ice in the US happened in 1925, thanks to the pressed air devices. They had the idea of containing and compressing CO2 and attempted to sell compressed air solutions like tire pumps, grease guns, and creating soda water at home. The only successful product they created was the very first CO2 fire extinguisher. They were also able to sell their solid dry ice product to railway companies as a cooling alternative to regular ice, which took hold in the railway industry in 1932. Well, that's it for a sneak peek of our website. Make sure to hit that like and subscribe button. I hope you enjoy our later videos.